All right. So first of all, I'm going to start up here, everyone, with the equation sheet. And let me just show you this. So first of all, we've got, let me remind you that on the equation sheet, like these top ones, these are all from unit 1, okay? And then these equations here, these guys here, those are from unit 2. And then these equations down here, those are from unit 3, right? And then this is the only thing you need to know for unit 4. Like we talked about, we watched the video of the bowling ball and the feather, and we talked about how no matter what your mass is, your acceleration due to gravity near Earth is negative 9.8 meters per second squared. So unit 1 is about motion, unit 2 is about forces, and unit 3 is about energy. And so when you look at this first problem, because it asks you to draw a free body diagram with forces, right? We know this is going to be a unit 2 problem. So one of the things that people ask me is, how do I know which is like corresponds to unit 1, unit 2, unit 3? Well, as soon as you see draw a free body diagram, that's unit 2. This problem, as soon as you see an LOL, that's unit 3, that's energy. And this problem, because there's no free body diagram and there's no LOL, this is unit 1, okay? So right away I look at this problem and I know I'm looking at these 6 equations up here. And then, like I said the other day, because we know that we're accelerating, because gravity accelerates things, I know we don't have constant velocity. So it's not, so those 2 equations are out. Then the other thing that you hopefully remember I told you is that these 2 equations we use for LT5A word problems, and these 2 equations are the same, like these are the same and these are the same, but they're different format, and in this format is for LT5B, proportional reasoning, okay? So right away, I know that for that problem, I'm using one of those 2 equations because it's unit 1 and it's LT5A. So now let's go and see which one we're using. So it says a t-shirt cannon is conducting tests to see how high it can launch prizes at a sports stadium. Assume the cannon launches shirts from the ground level straight up into the air. If it shoots a t-shirt with an initial velocity of 21 meters per second, how long does it take to reach the maximum height? Okay, so the question is this. Is it asked, do we know anything about height? Do we know anything? Are we asked to solve for height? And the reason I bring that up is because when I look at this equation here, remember, this is how we write it for the x direction, but in the y direction, if we're moving up and down, we write it like this: y equals 1/2 at squared plus v initial t plus y initial, right? And remember, anytime it's just blank like this, it's really talking about the final, okay? And so the y corresponds to height. Okay, so if there's no mention of height, then we're not using that equation because that equation has height in it. And since there's no mention of the actual value of height, we're going to use the equation over here, the one that just has velocity. So I look at the problem and I read it again. I see it. A t-shirt cannon is conducting tests to see how high it can launch prizes at a sports stadium. Assume the cannon launches shirts from the ground level straight up into the air. If it shoots a t-shirt with an initial velocity of 21 meters per second, how long does it take to reach the maximum height? So the equation that I just showed us is this one: V equals AT plus VO. And so this V is VF, remember? So you can always put that F in there just to help you remember that it's the final. So the final is this. It's asking us, how long does it take to reach the maximum height? So it's asking us to solve for time. That's our unknown. So we got to know all these other values. So let's see if we can figure them out. Well, the final moment is the maximum height. And what we know when things are launched up and they reach their maximum height is they stop for a moment. So that means the velocity is 0, right? You stop at the maximum height, which means the velocity is 0 at the maximum height. We know that the acceleration due to gravity near Earth is negative 9.8. T is what we're solving for. And it tells us right here what the initial velocity is, right? So it's 21. All right, so from here, it's just algebra. So the next step we're going to take is we're going to subtract the 21 to the other side, because you see that it's being added on and you want to do the opposite of that. So it's going to be negative 21 equals negative 9.8 times t. So then we're going to divide both sides by negative 9.8. So I'll bring this over here. So negative 21 divided by negative 9.8 equals t. And that comes out to be right around 2.1. And you know you've done it right or correct when you see the negative signs cancel out, because you can't have a negative time, right? So we know we've done it correct because those negative signs cancel out. So, if you plug in your calculator, you're going to get around 2.1 seconds is time. Don't forget to put your units in there. All right, any questions on part A? All right, so in part B, we got calculate the height it will reach. So now we're going to use our other equation. The other equation looks like this: y equals 1/2 at squared plus VOT plus YO. Okay. So remember, anytime you got this blank thing, you can put an F in there for final. So calculate the height. So that's what we're solving for. We're solving for y final, which is the height that it reaches. So the height, maybe let's call that h, equals 1/2 acceleration in free fall is negative 9.8. The time, we just found that up here, is 2.1. So times 2.1 plus, remember it tells us the initial velocity right there is 21 plus 21. Again, times the time, which we found over here, is 2.1. Plus y initial. And we always make the lowest height something's at 0. So it starts initially at a height, the lowest height. So it starts at a height of 0. Then you just plug all that in your calculator, you'll get what the height is, right? I can do that real quick for us.
Don't you have to square the first time?
Oh, man. Yes. Thank you, Sydney. I was testing you. You passed. No, I made a classic mistake. Students make that mistake all the time. And then now you just saw me make it. Absolutely. In the equation, time is squared. So we got to square that 2.1. All right, so there we go. Now let me plug it in my calculator. Okay. All right, so I get negative 21.6 plus 21 times 2.1. Sorry, my kids are being a little loud. 44.1. So then I get a total height of 22.5. So the t-shirt cannon fires the t-shirt to a height of 22.5 meters. Okay. Our time is up. If anyone wants to stick around, I was going to do maybe number 4, which is a proportional reasoning one. So if you want to stick around, I can do that. Before you go, let me just say a couple more things real quick. Thanks for coming. Gavin, you and I need to sort out a time. So let me check. Oh, not Gavin. We already sorted out a time. I mean, Dorian and I need to sort out a time. Sorry, Gavin. So I'm going to do this problem. Then Dorian and I are going to check in. And then if anyone else has more questions, you're welcome to stick around even longer. But I think that's about it. So I'm going to do 4. So I recommend, if you don't have anywhere to be, stick around and watch me go through this. Okay. Otherwise, I'll see you tomorrow. Make sure if you're leaving, make sure you finish this and submit it. All the more reason to stick around. You don't have to do this one. All right, I'm going to go over number 4 here. When Mr. Wolf jumps straight up from the ground, he has a vertical maximum height of 0.75 meters up. When he jumps straight up from the ground on a pogo stick, it takes him 4 times as many seconds to reach his maximum height. Okay, so here's the thing I want to show you. Right off the bat, I want to show you that because this is now proportional reasoning, we're going to use the bottom 2 equations, right? So it's going to be one of these 2. And because it's talking about height, we're going to use this equation. And this is super important. I mentioned this the other day. We always will assume with proportional reasoning that the initial velocity is 0. So the equation gets as simple as that. That's what the equation becomes, because proportional reasoning is just too difficult if this part is still around. So you can assume that the initial velocity is 0 for this problem. So here we go. Let's do it. Now it'll go pretty quickly. So it's going to be, and instead of x, we'll use y. So the equation is going to be delta y. And remember, this is proportional reasoning, so we want to put our placeholders there. Equals 1/2 a t squared. Don't let me forget about that squared. It's super important this time, Sydney. Okay, so we got to put our placeholders in here. Now, what we know is this: by what factor is the height different? So height is the y, so this is our question mark. We want to know by what factor that changes. Now, we're still on Earth, so gravity, whether we're on the pogo stick or just jumping up and down, is still 9.8. We can't change that. So that's a 1 because it's the same. There's nothing you can do to change the 1/2. You could change the height, you could change the planet, you could change the time, but you can't do anything to change the 1/2. So that's a 1 because you can't change it. It stays the same, whether you're jumping or on a pogo stick. So, and it tells us that it's 4 times the time, 4 times as many seconds. So now we've got our equation, which is question mark equals 1 times 1 times 4 squared, right? So 4 squared is 16, so question mark equals 16. So the vertical is going to change by 16 times. So it's 16 times his old value, which was 0.75, 16 times 0.75, which comes out to be 12 meters. Okay, so there you go. Those are 2 examples for you. I think that's everything. Make sure you finish this up and submit it before the end of the day so that I can give you credit for it. If you have questions, stick around. Dorian, stick